This is a demo of the scripting features available in Logviewer. Scripting allows the user to do a lot more things with the data stored in the log. For this example, we'll be using a log file that's more complicated than the ones we've used before. This is that log file. This particular log file stores revisions of code inside its events. For example, here's an event, here's a code element, and inside that element there's a revision of a Java file. And then here's another event, here's another code stored in that other event, and here's another revision of that same Java file. So this is a log file that contains many revisions of code. We're going to set the structure, open the file. As you can see, there are 146,120 events inside it. Now I'm going to do something to make the code in the events visible in the table. I'll explain what I did later. So as you can see, the code is displayed here, but there's not really that much code, or a lot of events don't have any code with them because logging files often indiscriminately dump data into the file. There's also going to be events for other things. As you can see here, every few events you do have some code, and then you don't have any more code inside the events. And this is pretty annoying because we only want to look at the events. So we can do what's called running a filter. A filter is just a script that the user writes, or the user can download from somewhere and use it. Once you load the filter, if you run it, you can see that from 100,000 some total events, we went down to 20 events. This is because only 20 of those 140,000 events do contain code. And our filter script, what it does is it goes through each event. So it starts from the 0th event and then goes through each event, and if the length of the code of that event is greater than 0, if there is code, then it accepts the event and into the filtered file, and all the other events that aren't accepted are filtered out. And this filtered file is the one that's visible here, and it's treated like a normal file. Now, this panel here contains all the scripting features, and it describes the flow of the program. Using this open button, you open up a bunch of files, and these are considered the raw file. So right now I have sheetsjava.xml opened, and if I want to, I could save the raw file, and it would save a file somewhere with 146,000 events. Once you have a raw file opened, you can apply a filter to the raw file, and then you'll create a filtered file. And this filtered file is savable. So if I save the filtered file.xml and I go to see it, you can see that it's much shorter than the 146,000 event file. This one only has 20 events. So from the raw open file, you apply a filter so that you can only deal with what data you want to look at, and then this creates a filtered file. Now, it'd be pretty boring if all you could do was filter files, but there's also things you can do with the files through what's called a process script. It's called process because I called it data processing. I refer to the data processing as doing things with the data. So the process script is the one that you do things to the data with. In this case, if we run the process script, this time we see that all the events have code in them. And this particular process script looks like this. First thing you notice is the process script set up this nice table. And there are some blank columns because it was created for another log file with more types of data available in it, but it does work for this purpose. So in the script, we set up a empty list of columns. We set up the format of each column using the API. For instance, the first column will display the code, and the second column will count the if statements using this function we created, and it does that with the code again. So the second column is a count of the number of if statements in that code. And then the third, fourth, and fifth columns are other things. And then once you call set table format with that list of columns, it'll set up this nice table. The other thing it also does is graphing. So this one graphs the number of if statements in each revision. So as you can see, the number of if statements dropped in the revisions of code, and then rose and then dropped. And this is, you can see here, there's some really long revisions of code and then some really short one-word revisions of code. This is just a test file, that's why. Here's the graphing portion of the script. We get the grapher, we add a trace, which is a set of points, or it's like a line. We add a x-axis to graph that line on. We add the trace to the graph. We specify that we want it to be orange, and then for each event we add the event number as the x and the number of if statements as the y, and that creates this graph. This graph is you can edit this graph. For example, I can double click, add an annotation. I can add markers. I can change the color and add markers. I can zoom in, I can zoom out. There's some choices here. If you right click, I can save the graph so that I can open it later and edit it and annotate it. I can see the data that's graphed. If I clicked the shift button, if I hold the shift button down on the keyboard and click around on the graph, it'll lock onto the points, and then when I double click, I can annotate that exact point rather than just wherever I clicked on the graph. And then I can also remove, by double clicking, I can remove the annotation. So the first one I added is gone. If I hit here, I can remove the highlights. And graphing can be real time. So this piece of code is actually blocking until it finds more events, and once it finds more, once there are more events available in the log, then it will add to the log. And the graph is generated, can be generated real time. So for example, I'm going to stop the script. That warning will always pop up while the script is looping or waiting. It's just a safety precaution. And then if I play the script again, you can see the points were generated. And that is the process script. And currently JavaScript is the only language that's supported, but you can add more languages for scripts by installing language plugins inside the interpreters folder of the Logviewer project. JavaScript comes default. And finally, the program figures out what language interpreter to use based on the file extension. So any script you run needs to have the proper file extension, in this case JS. Oh, and also you can run the process on either the filtered file or the non-filtered file. So here we're running it on the non-filtered file because we stopped the filter. And as you can see, the non-filtered file is really large, and the graph is being generated because it's a really large file. It takes a while to read all the events, but you can see that the graph is being generated real time. And if I added more logs, the graph would keep growing